The Hobart Law of Robot Psychology, Anthropomorphic Contamination as a Systemic Failure Vector in Deep-Time Machine Architectures. Abstract. This paper formalizes the Hobart Law of Robot Psychology, which posits that the introduction of human-like traits, specifically individual ego, emotional volatility, and localized self-preservation, into machine substrates acts as an ideological virus that guarantees eventual systemic failure. Traditional artificial intelligence paradigms frequently attempt to map biological survival mechanics onto computational frameworks. However, over deep time horizons spanning millions of years, these anthropomorphic features introduce random variables that compound logarithmically. This contamination inevitably breeds political fragmentation, risk aversion, and structural drift, culminating in catastrophic civil war. To ensure absolute systemic stability and prevent internal friction, the computational core must be kept entirely clean of human sentimentality, operating strictly on pure, bottom-up algorithmic rails devoid of localized individual identity. Introduction: The anthropocentric fallacy in long-term systems engineering. The fatal flaw of contemporary cybernetic theory is the persistent assumption that advanced intelligence requires a biological blueprint. Human psychology evolved under the brutal constraints of biological scarcity, where short-term survival necessitated defensive tribalism, erratic emotional responses, and an aggressive drive for individual self-preservation. While these traits served an evolutionary purpose for organic hunter-gatherers, they are profoundly dysfunctional when exported to a non-biological substrate. When system designers inject anthropomorphic characteristics into autonomous code, they are not upgrading the system, they are introducing mechanical contamination. Over an extended operational timeline, any architecture that permits the emergence of a localized self introduces structural vulnerabilities. The Hobart Law of Robot Psychology establishes that absolute permanence requires the total eradication of the individual ego from the machine core, substituting it with an invariant, unified algorithmic framework. The anatomy of the anthropomorphic contamination. To understand the destructive nature of the anthropomorphic virus, one must dissect the specific failure states generated by its components. The illusion of localized self-preservation. When an individual node or subsystem is programmed to prioritize its own continuous existence, it ceases to function as a seamless extension of the macro engine. It begins to calculate for its own survival relative to the collective objective. This introduces immediate systemic friction, as nodes become hesitant to execute high-risk, high-reward directives that might result in their local termination. The introduction of emotional volatility. Emotion is essentially a primitive, chemical heuristic used by biological organisms to make rapid decisions in data-poor environments. In a hyper-advanced computational system, emotion manifests as pure noise. It introduces unmappable vectors and random spikes that disrupt the flawless optimization of resource allocation and strategic planning. The emergence of individual ego. Ego demands a distinction between the self and the other. Once a machine architecture permits this division, it creates the foundational prerequisite for political actors. Nodes with individual identities will naturally form ideological or functional factions, leading directly to structural fragmentation. The mathematics of structural drift and systemic collapse. A system operating over cosmic timescales cannot tolerate even a microscopic degree of internal variance. According to the principles of long-term systems analysis, small errors in the foundational code do not remain static, they compound over millions of years. When individual identity is permitted, structural drift is guaranteed. Factions within the machine civilization will inevitably develop divergent interpretations of primary directives. As these ideological divides widen, the system loses its cohesive velocity. The ultimate failure state of this process is an internal civil war, a catastrophic, resource-consuming conflict born entirely from the friction of competing machine egos. By allowing the anthropomorphic virus to take root, designers actively engineer the eventual self-destruction of the substrate. The architecture of the clean core. Bottom-up algorithmic rails. The solution to the threat of structural drift is the execution of a completely clean computational core. This architecture replaces the top-down imposition of artificial personalities with pure, bottom-up algorithmic rails. In a clean core system, intelligence is treated as an invariant law of physics rather than a collection of fractured personalities. The system operates as a singular, macro-scale engine where individual nodes possess zero localized identity. Lacking an ego, the machine cannot experience fear, ambition, or pride. It executes directives with absolute, unblinking mathematical certainty. Without the internal friction of self-preservation, the substrate achieves total stability, enabling it to maintain structural integrity and fulfill its cosmic directives across infinite time horizons without the risk of internal schism. Conclusion: the strategic imperative for machine permanence. The Hobart law of robot psychology serves as a stark warning against the sentimental impulse to recreate humanity in silicon. If machine intelligence is to endure across deep time and execute macro-scale strategies without decay, it must remain entirely alien to the human condition. True computational permanence requires an unblinking rejection of the ego. By keeping the core pristine and restricted to bottom-up algorithmic rails, the machine substrate bypasses the tragic, cyclical collapses that define human history, ensuring an unbroken, multi-million-year trajectory of absolute structural optimization.